Hey guys, Nick Maxwell here. Futaba recently released the 1.3x software version for the CGY750, and so in this video we're going to kind of go over the updating process, the initial setup on the bench, and then some flying tips. The first step that you want to do is go ahead and get on futabarc.com and download the latest CGY750 update. It'll be labeled 1.3x. If you have the drivers and everything for this Futaba CIU2, then you're good to go. If not, download those drivers and with the CIU2, plug it into your SBus port in the Futaba CGY750. Next, you're going to want to go ahead and open up your file, and there's going to be two different files in there. It's going to be a blank page and a CGY750.bin. That one you won't need to do anything with, and then below it there'll be a folder and it'll say update. Just simply extract all files from that and it'll show a little CGY750. Click that update and it'll come up with a small box that says update and a couple blank bars with the word write. Next, you're going to need to go ahead and get one of the little Futaba programmer pokers, and as you're powering up the CGY750 through any of these ports down here, no problem. Do not power it through the R sensor or the gyro port. Hit the plus mode button and turn on the power, and you'll see the little words that say update ready. At this point, we're ready to go ahead and put in 1.3x. After the green bar has passed all the way from the left to the right, it'll slowly come up with a little box that says this update has succeeded, and on the CGY750 you'll see a little success. At that point you can go ahead and just unplug the CIU2 and unplug your power, plug back in your receiver, and on the very first power up, what you're going to want to look for is a big NINT data, and that just says, hey, I'm updated and everything went through okay, and then you'll see version 1.31. At this point, then we can go ahead and start setting up the helicopter. You're done with your computer and the rest is done with the poker tool and your radio. Okay, once you've double checked that you saw that initial data when you first powered it up, I won't show it again, but just as long as you're sure that that showed, go ahead and power up your radio and power up your helicopter. And one thing, if you've been currently flying the CGY750 on your helicopter, it'll probably be okay. But if it's a new helicopter or you're questioning the servo centers or any sub-trims, make sure to remove all the servo horns so you don't cause any binding or anything like that. Also, one other thing, with this new firmware, it is necessary to do a complete reset up of the swash menu and things like that, and make sure that your drivers are going the right direction. It's a completely different control loop, so as things are working, it's actually a whole different process, and I'll explain as we go through. I'm just going to go ahead and put in the numbers. I've flown this Raptor before, so I'm going to go ahead and throw in the numbers that I know work in this, but I'll explain why those numbers are there. Oh, and also, I'm very sorry, the servos are buzzing, but everybody knows that it's annoying, but part of setup. Okay, so we're going to go with data plus button to swash set basic, and see standard is H3 120. This model is a 140 ccpm, so I'm going to hit the data plus to 140 and double hit it again to confirm when the question mark comes up on the CGY. And we're going to hit the plus button again. Servo type. For really high performance servos like the 272s, the 255 HV, stuff like that, you can go ahead and turn the hertz up quite a bit. On this model I run 285. Analog servos, make sure you run in analog, otherwise it could cause problems and possibly burn up the servos. And if you're having servo heat problems due to different geometries and things like that, as you lower the hertz, the temperatures will go down. That's something that probably is best to refer to some of the other guys flying those specific models and stuff like that. On the Raptor, I haven't had any problems running them at 285. Okay. Heli size, 600 to 700, and that's what this is a 700. We'll leave it there. Flight mode. I'm going to explain a little bit about flight mode. Not only does it change your normal angular base, so when you hold full stick, what flight mode will do is change how quickly it lets that roll. Now, it also changes the overall control feel, how quick it is off center, how aggressive it is off center. So for sport pilots wanting to run a little bit softer feel off center, something a little bit more dialed down, the lower flight modes are best. For somebody wanting the most aggressive, stick banging, blade fart, all that kind of stuff, turn it up to flight mode 5. I personally prefer flight mode 3. And I'm going to go into a little bit later. I like the feel of flight mode 3. And if you're like that, if you play around with the different flight modes and you say, okay, I like the feel of this, but it's rolling too slow. Or I like the feel of this higher flight mode, but it's rolling too fast. There is actually an angular rate adjustment in the expert menu. So we'll get to that in a little bit. So I'm going to go ahead and set this to flight mode 3. Servo combo, this is a great feature. You don't have to individually reverse everything now, and this also tells which direction the compensations and stuff are. So obviously that isn't right. So let's hit the plus data. This is combo number 1. We'll go to combo number 2. Right, left, down and back, negative and positive. Okay, well this is actually working. Everything's working in the correct order. Up, down, right, left. It's just reversed. Some models, there's actually about 9 different combinations. You can sit here and scroll through them until it's the right direction. But say you find a combo that works, say I'm going to stick with number 2. Just hit here, aileron neutrals and stuff like that. Just go ahead and make sure that your stick is at middle. And in swash set menu, your gyros will be off, so you don't have to worry about any of that. Make sure your swash plate's level, your blades are 0 pitch, and then you're good to go on all the neutrals. That's the same as before. Aileron rate, this is what we were talking about in the combos before. I just settled for a combo. Some helicopters, like I said, you can come up with one where everything works in the right direction when moving the sticks. In this case, my aileron is correct, my elevator is reversed, and my collective is reversed. So first I'm just going to go ahead and set up the aileron total pitch. So we'll move the helicopter. I'm going to put a pitch gauge on the blade. This is where this firmware version differs a lot from the original one or the last couple of updates. This is not anymore your rate control. Your rate control is done by that angular rate number in the expert menu that we're going to talk about in a little bit. So what you want to do is go ahead and statically measure 0 pitch. And with full aileron deflected, you want to be somewhere between 8 to 10 degrees. This is just a calculation and a measurement for the gyro to know, okay, this is about where I need to be for 8 to 10 degrees. And this varies with different helicopters. If you're flying a heavier blade or a more stable blade, you're going to want to actually run a little bit more cyclic pitch. If you are running a real light 3D blade, maybe you're down in the 8 degrees. Now this does not set your limits. We're actually going to set your total swash plate limits in the swash ring, which is in the next parameter. On the Raptor here, I just happen to know that 10 degrees is 64. Now what we're doing is we went from positive number to a negative number, and as you can see, that's slowly reversing the stick input. So you don't actually have to reverse anything in your transmitter, and it's perfectly acceptable to run these into negative numbers. So set that at 64. Collective pitch is the same as before. You can run whatever, doesn't matter, whatever feels best to you. So I think I was running 48. And once again, we have to reverse this. Actually, no, that is the correct direction. Okay. So there's 48. Now everything's working in the correct order. Up, down, right, left. I'll tear it in there. And collective. So now the next parameter that we have here is the swash ring. This is what gives you the total swash area that the travel, as you can see, all of a sudden we have a lot more now than what we did even just in setting those aileron and elevator rates. So in this case, I want to go here. Okay, I don't have any binding. So I can increase. That's at full negative. It's at full positive. I still don't have any binding. So I'm going to go up to 128, which is I know where the Raptor's happy at. You can see there's no binding there. Full negative and full positive. And so just use that swash ring number to get it so you can get the most maximum out of your helicopter. Once again, you don't want any binding. If you have binding, that could pop a link and cause you to crash. If you don't have enough swash ring, say you're just erring on the cautious side for binding, and in flight, if you feel like say you're doing a roll and you give some elevator and the model feels a little sticky or like the elevator isn't quite as sensitive, most likely you're running a little bit out of the total swash ring. So we're going to go to the next parameter, which is aileron stick direction. This is very important to double check because this is what all of the newly added compensations are in the system. So what we're going to do is hold full right aileron, and you'll see a little exclamation point if it's already correct. So this one's correct, but I'm still going to hit the negative data number, and that will set it so that it knows what right aileron is. Go to the next parameter, stick direction. For elevator, up. By up, they mean up like an airplane, so pull back on the stick. Negative data, saves it, exclamation point. Okay, now what we're going to do is go into the pitch low and the pitch high. This is also very important to set because this is what the compensations are based off of. So we're going to go into where our most collective pitch is, which in my case it's in my throttle hold. Go full negative, hit the negative data number. Then we're going to go to the next parameter, which is pitch 0. So set it so that your radio is just as close to 0% as it possibly can be, and hit 0. And since our blades were at 0 in our sub-trim setup, we know that they're still at 0 pitch. And we're going to go to pitch high, which is the next parameter, and hit the negative data again. Okay. The next parameter, it says FF mix. This is a feed-forward mix, which is basically all of the compensations. And what Futaba's done is they've put them into one number. We found a basic group that really works well on pretty much all the helicopters, but it exponentially increases everything the same. So as we hit these feed-forward mixes, say you go full negative, what you're going to want to see as you increase it is up elevator and right aileron as you increase that number. So now we're up to 10. So before our swash plate was traveling really straight and true. Now this is normal. As you go up, see we've got now down elevator and left aileron with full positive, and up and a little bit of right. The aileron is really hard to see, so you have to turn the numbers up. The way to set this number is as you're flying, do some pitch pumps. Just go from full positive to full negative or climb up and down and watch the nose. If the nose is staying flat as you do that, your feed-forward mix number is set correctly. If it's too high, what you'll notice is it'll go in the direction of the feed-forward mix. So as you push negative pitch, the nose is going to come up. As you push positive pitch, the nose will go down. So you just have to play with that number a little bit. A good number for 90 size is around 5 or 6. A good number for 450 size, they have a lot lower torque. This is actually a torque compensation as you increase the torque of the blades. So the higher, the 800 size helicopters could be all the way up to 10. Some, same as scale with a really slow head speed, could be up to 10. Like I said, most 90s are happier at 5 or 6. So we'll set that to 5. And phase equalization, I have it turned off because I don't have any sort of governor set up on this. I'm actually using an internal governor. But on a nitro, where the RPM is calculated in the CGY750, go ahead and turn that on. You can also manually input the numbers in here, but I found that using internal governors with battery fluctuation and internal governor differences, I wouldn't rely on that because if the RPM is a little different than what you're putting in, it could mess up your pirouettes. So it's best just to leave it off. The performance is very good anyway. Rotation equalization, that's your pirouetting comp. I'm going to go ahead and turn that on. And the next parameter behind that is equalization direction. So what we're going to check is, as you see, the swash plate goes down like this. As we turn the helicopter, the swash plate should always stay pointing in the same direction. So as you see, it had up elevator here, but as I turned it, it went to right aileron, which means that the pirouette compensation is reversed. So we'll reverse it. Now the swash plate should always point in the same direction. So as I rotate the helicopter, now we have down elevator. Now we're going into right aileron, back to down, back to left. So the swash plate should always stay at the same angle. And when we come out of this, rotational track, that number is, this is an in-flight number. If you say you have a right pirouette that's a little wobbly compared to the left, using the rotational track will get that disc nice and level. And that's it for Swash Set Basic. Okay, the next subject we're going to go on to here is the rudder setup. Nothing has really changed in the general setup, so I'm not going to go over that. But in the expert menu, which how you enter this is by holding down the plus mode button, you're going to see expert. And now I wouldn't recommend adjusting any parameters other than just the one that we're mentioning here in the expert menu. This is specifically for electric helicopters. Nitro, I wouldn't even worry about it. But the motors are so torquey and everything happens so fast with these bigger, heavier electric helis. It's best to have a little bit of that feed forward. It's the same thing that we discussed in the SWASHPLATE setup as we went from positive to negative. It's just a little mix that helps the gyro compensate, pre-compensate. So we're going to scroll through here. We're going to look for a parameter that says FF active. Or excuse me, FF mix, and then it'll say active. And then the next parameter directly after that will be two numbers. And this one already has some programmed in it, but you'll notice that there's a high and a low, and this is changed based off your collective pitch. So as we increase pitch, what you're going to look for is the tail rotor to increase or give a little bit of right rudder. And then at neutral, it'll be neutral. And then as you go full negative, the tail rotor will increase right pitch just a little bit more again. And this number, just kind of play around with it. It's a little bit like the feed forward with different size tail rotor blades and things like that. It could use different numbers, but it's positive and negative, so just make sure to check it before you fly. If you put, say, off a zero stick left rudder in, your tail rotor will perform pretty bad, so you'll know quickly. But yeah, that's a good thing. That's a key little trick to some of the electric. For some of the electric helicopters out there. To exit the expert menu, we're going to hold down the plus mode button, and that'll put us right back into rudder gyro basic. Okay, now we're going to go ahead and get to the aileron basic menu. And all we're going to do right now on the bench is just, I really think that you should fly this latest update as stock expert settings. First try it and see what you think, and then a little bit later on in the video we'll go over the in-flight tuning with some of the expert menus. But the only thing you need to do now is just scroll through. You'll see aileron gyro basic, hit the plus button, and you'll get an aileron direction, normal or reversed. So you just check to make sure that your swash plate is trying to stay level as you tip the helicopter. So the swash plate always moves into the lean. Okay, so this is good at normal. So we'll go ahead and exit that, scroll through. This also shows your gains. It's actually kind of neat in the basic menu. If the parameter right after reverse, it'll show you the gain from your radio compared to a total gain, which is kind of just a nice parameter. You can see where your transmitter gain is. Okay. Now we're going to hit the plus mode, plus data button again to get us to elevator basic. We're just going to do the same thing. Aileron direction normal, tip the helicopter up, and the swash plate should try to stay level. Okay, so this one happens to be normal, but make sure to double check your gyro directions. That is a nasty crash when that happens. So definitely double, triple check those directions. Okay, so now that we've done all the bench setup regarding the electronics and stuff like that on the CGY750, now I'm just going to kind of go over a couple tips and tricks that mechanically make your helicopter fly a little bit better as well. Most importantly is the CG. You want the lengthwise CG to be absolutely neutral. If it's not, unlike a flybar model where there's a proactive stabilization that is responding to the disc, not necessarily the body's changes, with a flybarless, wherever the body goes, the gyro senses and tries to move the disc, so those things stay connected. So if the CG's off and it's wobbling the disc, you're going to get some gyro interaction. So what you want to do, and now my helicopter has no batteries or no canopy or anything, so it's going to be real tail heavy. But as just a general test, what you want to do is just go ahead and let go of the model, and it'll fall either nose heavy or tail heavy. And on electrics, there's motor cogging, so I'd recommend flipping it 180. And it should just stay there like this on both sides. So that's a good CG, and that'll really help with your pirouettes. Another thing that just generally helps with pirouette performance and even aerobatic performance is with the swash numbers. When you set those, when we measure the 10 degrees, make sure that those numbers are the same. And then also in your radio, you want to keep your aileron and elevator gyro gains the same. Since the pirouette compensation works off of a gain parameter or based off of the gain correction, you want those numbers to be the same, because if, say, the aileron the gain is higher, so it's sensing more change, it's going to wobble it in that direction where the other direction might not, so it won't correct as much for that. What I've done in my radios, on all the radios that have the function menu where you can assign channels, like in the 18, the 8FG, the 14SG, those models, go ahead and just make the aileron and elevator gain the same channel, and then it'll run it up. You'll just have basically a general cyclic gain. Okay, so that's it for the CGY750 setup and some flying tips. I really hope you guys enjoy the performance of this new update. I know I really have, and I look forward to seeing everybody out at the field.